Hey guys, so I'm going to do two example problems for your problem set today. One with a series circuit and one with a parallel circuit. If you look below the series and parallel circuit example problems here on Canvas, you'll find the problem set which contains these problems. So what I would like you to do is just copy down as I do them in your notebook, alright, and then you'll have basically the first two done already as you move on from the videos. So the first one is the series example problem. It looks like that when you open that document below the videos. Copy it in your notebook now, alright, from this picture right here, okay? Okay, so we have three resistors, should all be copied in your notebook, a battery here, and we could have an indication of a current flow, and they give us the resistance of each resistor. Alright, it's a series circuit, they're all in one loop. Alright, and the problem asks us to calculate the voltage dropped at each resistor, then calculate the voltage of the battery. Alright, so what we're going to use is Ohm's law to do this. Alright, so we're going to say for R1, we're going to calculate the voltage dropped at R1. That's the V in Ohm's law. Alright, so V equals IR for R1. Alright, so it's going to be R1, and the voltage dropped at R1 is going to be called V1. So to calculate the voltage drop there, that's V1. We know the current is 3 amps. In a series circuit, the current is the same everywhere because there's only one loop. So we could just plug in 3 amps for the current is the current through every resistor, including R1, which we're focusing on right now. R1 here is 2 ohms. Alright, they give us that. So the voltage drop there is equal to 3 times 2, or 6 volts. You do the same thing for R2, but it'll be the voltage dropped at 2 equals the current times R2. Once again, the current is still 3 amps because in a series circuit, the current is the same everywhere. The resistance is different there, and because there's more resistance, it's going to be a bigger voltage drop there. 3 times 4 is 12 volts dropped at the second resistor. Okay. Continuing on, R3, we're going to say V3 equals I times R3, alright? So V3 equals the same current because the current is the same everywhere in a series circuit. There's only one loop. So we say 8 ohms is our resistance there in R3. So the voltage dropped at the third resistor is 3 times 8, or 24 volts. So we found the voltage dropped at every resistor. At the first one there was 6, the second one there was 12, and at the third resistor there was 24 volts dropped there. Finally, we want to figure out what the voltage of the battery is. Okay, so we know in a series circuit, because there's only one loop, each electron has to split its pretzel drops, basically. They have to drop some pretzels at R1, some at R2, some at R3, and then they've dropped all their pretzels, and they pick up whatever they've dropped total, they pick back up at the battery. Alright, so at the first resistor, they drop 6 pretzels, the second one, 12 pretzels, and the third one, 24 pretzels. That's how much voltage they dropped at each resistor. So how much did they pick up at the battery? Alright, so we know the voltage of the battery equals how much voltage they dropped at the first resistor, plus the second, plus the third. Remember, this is only for a series circuit. Doesn't work that way for parallel. So the voltage of the battery is 6 volts plus 12 volts plus 24 volts. 6, 12, and 24 is 18 plus 24. So the voltage of the battery is 42 volts. Maybe just a bunch of batteries together right there. Okay? So use this example for all of your series circuit problems that you do. Okay?